We have the opportunity to talk today with Mary Bunzel, Portfolio Manager at IBM, and we are delighted to talk about the transformative nature of IoT for business. Mary has been involved with asset lifecycle management and industrial applications for a very long time, 29 years, and is very knowledgeable in this aspect.
Thank you, Ralph.
Mary, assets have been connected for decades now through semiconductor industry and other industries. It's expanded. Can you talk a little bit about how this has affected business today?
Well, the Internet of Things has really transformed the ways that customers are connecting to their assets, Ralph. It used to be many-to-one connection, where the ability to link into assets was built on a proprietary basis. It was all very intra-plant or facility, very limited in scope, and expensive to maintain. Technology has made possible now the ability to connect a many-to-many relationship of assets. And the sensors and the technology that's available at the asset level is so much more intelligent. Business rules can be enforced at the fringe of the network now, and the information that these assets are able to stream is so much more enhanced. At the same time, technology has evolved to bring this capability to the masses. So now even small companies and early adopters can experiment with very low-cost solutions to explore what the Internet of Things and applying business analytics to the intelligence from assets can do for them.
Well, I'm an engineer, and I really like the idea of getting more data. You talked about the streaming data for a moment. So we have this data coming in. Can you talk a little bit about what we do with the data? How is it analyzed, or what capabilities are applied to it?
Well, right now, I think, Ralph, the industry is still in kindergarten or first grade. The data is streaming in, these algorithms are developed and are developing an understanding of what a normal performance is. But as more and more information is gathered and accumulated, a ladder step learning can occur, and the models become more and more sophisticated. So obviously, IBM is focused on optimizing process and data analytics. And data really is the fuel for this optimization and analytic behavior. And it must be gathered at a local level, brought up to the cloud, and then mathematical algorithms are developed based on the feed from these sensors and the information coming in. But now that it's been able to be made available to a wide variety of innovators and other types of tools that to process the data, we're now learning more and more capabilities of what it can mean to us. And I'm really excited about some of the customer engagements that we've been involved in and the way that these tools have transformed their business. More to come on that, Ralph. Watch.
Well, as you know, Internet of Things is a major theme at the forum this week. A lot of speakers talking about a lot of sessions, very innovative discussions. Could you make the connection between the Internet of Things and some of the IBM solutions? You know, I know, for example, that IBM has been a leader in terms of applying it to infrastructure and smarter infrastructure. Could you give us a little introduction of the solutions that IBM offers in this space?
Oh, sure. Well, you know, this journey started back in 2006 when IBM announced our smarter infrastructure focus. And back then, even, we were focused on levering technology, not only from sensors, but also from process in terms of asset management and the use of business analytics over the top of that. Around the same time, Watson debuted with the Jeopardy match against past Jeopardy winners, and in fact, won that contest. And the way that we got there was to build computing environment that had the ability to process human language in a way that humans think, with loosely coupled algorithms and models of patterns and behaviors that it uses then to be prescriptive in its advice and what it feeds back to those who use it. So today, Watson has evolved now to a point where it's available to the masses. We have published APIs that innovators can lever when they're creating these industry-specific IoT solution stacks. So these APIs include that for, of course, human language processing, but also text and video processing, streaming data from assets, and also one for machine learning. So by making these tool sets available to open community of inventors and really smart people, then we can all work together to develop models and evolve to the point where it can become even more prescriptive. So data analytics, depending upon who you talk to, has a variety of meanings. To one customer, it might be a report that takes data from their history and shows it in a way that they can action against it. Others interpret data analytics to look for patterns and trending of changes in order to take action. We see Watson cognitive analytics as the ability to be prescriptive. And based on the continuous stream of data and analytics that's coming from assets, as well as co-joined information from other correlated factors, such as weather, for example, or traffic patterns, or major events, or other things that impact behavior, we feel that we have watched Watson evolve to the point where it can now give recommendations on next best actions.
Wow. Well, initially I was thinking about the Internet of Things providing mainly physical attributes like temperature, pressure, vibration, and things like that. But you're sounding like you're starting to talk about things that go beyond just these physical measurements. Are there other attributes that can be brought into this mix?
Absolutely. Consider the Internet of people and the flow of people and their behavior as an additional data source that feeds into the performance of assets and what they're needed for. So people as sensors can provide information that's valuable for businesses to respond to. There's a lot of ways that this is being experimented with right now, Ralph. One is in the area of health and safety. We're working with a large steel manufacturer on the use of people as sensors. So, of course, you have the environmental sensors that are monitoring the atmospheric elements in a plant or a process. You have also machine sensors that are monitoring what you mentioned, pressures, speed, temperature, things like that. Now, also, you have people who need to respond to that, to failures or trend to failures. Take an environmental sensor, for example, that might be monitoring methane gas in an environment. It's well known that 25 parts per million is your warning level. You must evacuate the area as soon as you hit 25 parts per million without taking into account the physical attributes of the person that's there. But what's the effect of a person being in an environment that's at 24 parts per million, accumulated for an hour and a half in the environment? And that session occurred towards the back end of their shift. So they've already been at work for 6 hours and have some fatigue and body stress. So the compilation of this kind of data in with Watson Cognitive Analytics provides a higher level of safety for this worker, because as soon as they start to experience stress, monitored by hexoskin vests and helmets that monitor body statistics. You offer a higher level of safety and care for not only the environment, but also people as well.
Wow, Mary, this is absolutely fascinating. We've been talking about industrial Internet of Things, analytics that go along with that, machine learning, and now into cognitive computing. Fascinating type discussion. Thank you. We've been talking with Mary Bunzel of IBM about IoT, analytics, cognitive computing. Fascinating discussion. Thank you for talking with us.
Thank you, Ralph.